Hey everyone, and welcome to our webinar. Today's topic is GraphDB fundamentals. My name is Yasin and I'm part of the Ontotext marketing team and will be hosting this webinar. Next to me I have Radustin who will be leading it. Radustin has a master's degree in software engineering from the University of York in the UK and has been on board with Ontotext ever since he graduated in 2016. He's a maintainer behind the Ontotext Cognitive Cloud and participates actively in core GraphDB development. Before we start with the official part, I want to point your attention towards a couple of housekeeping items. For practical reasons, all of you are muted, and this is to avoid background noises. But you can still ask questions and communicate with us via the question box in your GoToWebinar panel. Feel free to ask any question at any given time, and we will try to cover them during the Q&A session at the end of the webinar. In case we are not able to respond to all of the questions, we will send a follow-up email in which we will include all of the answers, so you will receive an answer to your question regardless of whether or not we cover it here. So, without wasting additional time, I will give the word to Rado to start the so-called official part. Rado?
Hello, everybody. My name is Radustin, and I'm joining Yasin here for today's webinar. As mentioned before, I'm part of the GraphDB development team, and I also participate in the Ontotext Cognitive Cloud development team. I also do a bit of DevOps, something of everything, so to speak. Today, we'll be covering a few topics, moving onwards towards the introduction part. We're going to be speaking about RDF, RDFS, we're going to give you a Sparkle overview. We're going to talk about ontologies, and then we're going to move on to the more exciting bit of the overall presentation, which is the GraphDB Workbench demo. So, swiftly onwards, what is RDF? RDF is the resource description framework. It's a graph data model. It describes the semantics or the meaning of information. In this RDF model, everything is a triple or a link. All values inside the links have to be valid to URIs. A graph would be a collection of links. Links take the subject, predicate, object pattern. So you would have a subject, which, for example, is let's say example.org/thing, a predicate, which is an example.org/type, and an object, which could be an example.org/object. That's a fairly quick introduction. Also, if you look at the slide towards the bottom, we have another example triple, which is BR Fred has spouse Wilma. Throughout this presentation, we'll be using the Bedrock ontology. In it, we try to model the world of the Flintstones animation series from the 90s, I believe, and the 80s as well. Here, BR represents HTTP Bedrock, so it's still a valid URI, even though at first glance it doesn't look like it is. Here, we're saying that in the Bedrock namespace, there's an object, Fred. This object has a spouse, and the spouse name is Wilma. Likewise, we say that Fred is 25. RDF use cases. There are a lot of use cases for RDF. However, it is good at some things and not so great at others. It is very efficient for representing information with high complexity, with semantic context, and when it's reused by multiple organizational units. It serves very well all sorts of analytic use cases. They're not optimized for heavy transactional processing. Let's look at 3 real use cases for RDF technology. Big media or public, well, the first case. A big media or publishing organization may need to maintain standard taxonomies to develop a master list of all internal information assets like articles, books, videos, or other types of multimedia content. However, each asset has a slightly different information schema. For example, a video would have a video format, it would have duration. An article, on the other hand, may have an article abstract, citations. Some other sort of multimedia may have other metadata metadata attributes. So, if we try to represent this in a standard SQL database, we may have many tables, or we may have a single table with many zero values. So, we want to turn to NoSQL. And here RDF is great for this, because it is good at treating every object separately. There's no schema which covers all the object, and it's very highly extensible. Looking at another use case, which ties to our previous one, we may have an information provider who want to make their data easier for selling. For example, they may have information about movies. However, they don't have information about the actors. Or they need, for some example, for some documentaries, information about chemicals which are used in those documentaries. Or they need information about politicians for whatever reason. So what happens is they're able to integrate this data by connecting it to public data sources. Because RDF is so extensible, it's very easy to integrate with other sources, and you are capable of suggesting better content based on what information you have. And this exactly is, in fact, our third use case. Large enterprise organizations store necessary information in big data silos managed by different departments. This is okay for transactional operations because individual systems are capable of implementing these existing business workflows. However, if you want to do cross-system analytics and people in different departments use different identifiers, their schema are not compatible, there's different structures, you would have an issue if you're using standard SQL technology. RDF is very good at extracting all the information with business values and semantically integrating it. Now we're going to look at some RDF schema and talk about how is it structured. Here we have a graph. You can see various squares. Those will be our nodes, and those squares are connected by arrows. Those will be our edges. Let's look at something in the middle. Fred Flintstone works for the rock query. Here, Fred Flintstone will be our subject. Works for is our predicate, and rock query is our object. You see that since we're schemaless, every single object can also be a subject in another triple. Here we have rock query as a subject, is located in Bedrock. This is how we build up our graphs. RDFS is an extension on top of RDF. It adds concepts such as resource, literal, class, data type. It adds relationships such as subclass, subproperty, domain, range. It essentially allows you to define classes, properties, a hierarchy, which in the end gives you the capability of performing inference. Inference is a key GraphDB feature. It is not unique to GraphDB, certainly. Other RDFS databases also have it. However, not each database, which is capable of working with triples, has inference. For example, Azure wouldn't be capable of inference, etc., etc. And moving onwards to display an example of inference. Here we have a domain and a range, and a relationship has spouse. The domain of has spouse is a human, and its range is human as well. What does that mean? Well, that means that the subject of has spouse has to be a human, and the object of has spouse also has to be a human. So both spouses are human. Therefore, we can infer that anyone who has entered matrimony is a human. Also, humans are mammals, so anyone who has married is a mammal as well. Therefore, Fred and Wilma are mammals. You can continue chaining this inference even further, explain that mammals are animals, and animals are a type of object, they're a living thing, etc., etc., etc. So, how do we query that data? Well, for that we use Sparkle. Sparkle is the Sparkle protocol and RDF query language. That's a recursive acronym. Why not call the S semantic instead of the recursion? I'm not quite sure, but that's how it was decided it would be named. As the name suggests, it's both a protocol and a query language. So it both describes how the communication between a client and a server would happen on a high level, and also explains the semantics of the queries which are sent off towards the server. Talking about queries, there's a few query types which we describe over here. Select, that would be the most common query which you send towards your database. Those are your searches. They return your data in tabular form with as many columns as you define. You can tell it that you need 20 columns, it's going to give you 20 columns. Construct, it creates a new RDF graph based on the results. It is not in a tabular form, it's necessarily triples. So you have subject, predicate, object in construct queries. Ask is Boolean, it gives you a yes or no, depending on what you ask. Describe, it gives you graph data about the resource, useful when you don't know what exactly you're looking at. For example, you've just opened up a new database which somebody else has been developing, and you want to explore some basic things about it. Those four in GraphDB are sent towards the Sparkle endpoint, which is the /repositories/repository name. And they are all typical in the fact that they essentially fetch information from the database. The next two are the insert and the delete, which are fairly straightforward. One of them inserts, the other deletes. The particular fact about them is that they are located under a different endpoint. So beside the standard Sparkle endpoint, you would have / statements. So it's a different URL which you need to call with those. That's important to remember because sometimes people make a mistake and they often wonder, why can't I insert data inside my graph? Well, maybe because we've forgotten to add the statements part. You can use Sparkle to insert triples. Later on, we're going to have another GraphDB demonstration, but if you want to, and you have GraphDB installed, you can try this. You can define the prefixes. First, here we have the prefix BR, is HTTP bedrock. And then we tell it that we intend to insert data. And we tell the database that Fred has a spouse Wilma, and so on and so forth. When we click the run query button, or when we hit the enter, if we're doing this via the command line, we're going to get a graph such as the one on the right. That's an example of insertion. How about querying? Well, for that we use the select. select tells you what the response will contain. So here we again define the prefix, and then we say that we want to select a subject, a predicate, and an object, where the where clause actually tells you what we're searching for. In this case, we have not bound any of those variables to anything. So we're just asking select subject, predicate, object, where they are, so a subject, a predicate, and an object. This will return the entirety of the database, as you see on the right. And accidentally, this is the default Sparkle query in the workbench. So if you have a GraphDB and you open up the workbench and you click open up a new tab, it will produce this Sparkle query, of course, without mentioning Bedrock, because by default, we don't live in Bedrock. And the only difference with the default query is that the default query is limited to 100 results. That's another Sparkle keyword limit, which tells you how many results you expect. Here, since our database is fairly small, that's just 4 triples, just ask for everything. Sparkle to find Fred's grandchildren. Straightforward, instead of select, we have ask. We're asking for a subject, Fred, which has a child. We don't bind that child because we're not interested in who the child is, so long as it exists. And we're also asking if this child has a child on its own. And we call that a grandchild. Turns out that, yes, Fred does have grandchildren. Fairly young, he's 25 and with grandchildren. So using Sparkle to find Fred's grandchildren, instead of having an ask, we may have a select. We know that Fred has a grandchild. So we can do a more resource-intensive query and ask who that grandchild is. What are their names? What we do is replace the ask with a select, and we say what we want to select exactly. And what we want to select is the grandchild. So we say select grandchild, the where clause doesn't change. And on the right, in the result box, we see that the Fred's grandchildren are Roxy and Chip. Now we're going to quickly discuss ontologies. Ontologies is formal specification. It provides shareable and reusable knowledge. So some examples of formal specifications include taxonomies, vocabularies, thesauri, topic maps, logical models. An ontology is what you use when you want to store some domain knowledge and share it across various instances, across various groups, etc., etc. This gives you the capability for having some specific data about your data. So in essence, it's useful for structuring and for metadata. Let's go a bit further and give you an example. So in this example below, we can specify that there are 2 individuals, Fred and Wilma, in a class of type person, and we know that person is a mammal. We also know that Fred works for the Slate Rock Company. The Slate Rock Company is of type company. So we know that person works for company. And from that we can conclude that Fred is a person. The relationship can work both ways. So here we say that an ontology, which specifies descriptions of concepts and properties in this domain, which is Bedrock in this case. So what are the benefits of an ontology? They're useful when you want to gain a common understanding of the information, when you want to make assumptions explicit in ways that can be used to support many activities. So you can develop a common understanding of the information, and you can have explicit assumptions. This is how you can perform data integration for analytics. You can apply domain knowledge. You can support application interoperability, enhance model-driven, and enable as well model-driven applications. Also, you may develop applications faster because you no longer need to define your basic assumptions, and improve data quality because you can now perform inference thanks to the ontologies. Moving onwards towards what GraphDB is. GraphDB offers all of that. It's an enterprise-ready semantic graph database, and it's compliant with W3C standards and with Sparkle 1.1. What are the typical use cases of GraphDB? Well, it's a leader in the science and technology and medicine publishing and media spheres. It enables the transformation from content-centric information model to data-driven models, where the knowledge in your unstructured text can be extracted with text mining algorithms and used as data. GraphDB is the selected database by a number of organizations such as Elsevier, Wiley, Springer Nature, BBC, the Financial Times. They want to take their content assets to the next business level. It is great when you have text with entities, persons, event locations, etc., and want to connect those and establish their relationships. It's a very good tool for modeling your graph data and building up a proper knowledge database. Moving on towards our most recent release. Actually, it's not 8.8 as the slide suggests, but 8.8.1. Now, that's a patch version. It's relatively minor and it fixes some fairly particular, fairly rare bugs. So here we're going to mostly talk about 8.8 because it introduced a lot of improvements. Some of those are better similarity searches. What you have in this version of GraphDB, and what I'm going to show you a bit later, is your capability to ask how similar to semantic entries from your database. Now you can also carry out predication-based semantic indexing. You also have improvements for our MongoDB plugin, so you can integrate GraphDB and MongoDB. There's now JSON LD serialization for talking between the two of them. There's a faster backup mechanism for the cluster. The cluster is a high availability tool available together with the GraphDB Enterprise Edition. And we also have a very important feature for those of you who are security minded, which is audit headers and request ID tracking. This makes debugging easier since you can track a request for a variety of services, and you can also take you can audit what what someone has just requested through the audit headers. Additional improvements include small optimizations, improvements to connector creation in particular, and we're going to talk about what connectors are in a moment, as well as upgrades to the latest RDF4J 2.4.2 public release. RDF4J is the underlying framework for GraphDB, and an upgrade means that we have better integration, faster performance, etc. Now towards what is probably the most exciting, which is the GraphDB Workbench demo. For that, we'll need to change screens over, so my co-host will now click on my name and tell me that I can present.
It should work now.
I believe you can now see my screen. Excellent. So to begin with, we're going to show you how to install your GraphDB, which is extremely straightforward. If you get the GraphDB distribution, which is available at our Maven repository, even without login details, of course, it doesn't come with a license. You can say that you want to download it. There it will come as a zip file. In this case, I've downloaded the Enterprise Edition. It's fairly small, but you can maybe see what it says on the screen over there. And I've already unzipped it. Now it's a portable resource, which means that there's a bin folder. And inside the bin folder, there's GraphDB.cmd. In this case, because I'm running on Windows, of course, we'll be running from the Linux shell otherwise, and you'll be running this, the GraphDB If I double click on that, and I tell Windows Defender that I trust GraphDB, voila, GraphDB should eventually start. And wonderfully, this is something which I tested like a few minutes ago, and now it doesn't want to do it. Ah, there we go. It took a while for some reason. So it's saying that it's starting GraphDB in workbench mode, which means that we'll be able to see the visual workbench. Here it says what the config directories, the data, work, and logs directories are. Of course, I can probably feed it with some settings to change that, but we're just working with the default here. Started GraphDB in workbench mode at port 7200. This means that now I can open it, which is going to be here. And this is our lovely GraphDB workbench for the first time when we've launched it. Now I have no valid license. I can upload my valid license. It is in the GraphDB fundamentals Ontotext internal license. There, unlimited course, valid until the end of this year, and we're going to provide maintenance until the end of this year. Voila! Now, the first thing when you want to work with GraphDB is to create a repository. A repository will host all your data for a particular namespace. You can separate various namespaces inside repositories, or you can define them as a different graphs inside the same repository. So I'm going to call this repository wine. We're not going to touch any of the other settings, but quickly going over, that's the storage folder name, that's the rule set, and this is just for inference. You can upload your custom rule set. Our same as it is related to ontologies, what's the base URL, how big the entity index is, things such as predicate indices, literal indices, context indices. Those just make your database faster in particular ways. You don't want to toggle all of them because, for example, if I don't have a bunch of contexts, I don't need a context index. But if I have many contexts, I can use this. Read only, that's fairly obvious. We won't be able to upload any data. We don't want that. Entity ID size 32, 40 is useful only if you use a lot of data inside of your database, which we won't. It will just be a simple small example, and we're going to create this. We're going to connect, which also initializes the repository. And we're going to import some information inside it. From RDF, there's a nice ontology called wine. That's how it looks like in RDF XML. It tells you what it's about. It's an example of our ontology, etc., etc. With GraphDB, you don't need to download this and then upload it. You can just copy the link location and upload the RDF data from a URL. There you go. It's this horrible Google thing. Since it doesn't actually do the redirect. Now it is the less horrible Google thing when I try it now. There, now it's imported. And you can see that inside the wine repository, we have 2,519 statements. Looking at a few of those statements, that's the default query which I mentioned. Here we say select everything which conforms to this pattern. And since this is the most basic pattern of a triple, a subject, a predicate, and an object, and that's a dot which says that inside the default context, we get everything. First, we have the RDFS plus triples, which are triples used for inference. We say that type is of type property, subproperty is also a property. This is useful when you want to infer things. However, there's actual information such as vin, this is the prefix for the wine dataset, has flavor, which is of type object property. This tells us that the has flavor URL is useful for defining, is an object property, and therefore is useful for defining properties. If I click on it, as I just did, we're going to see where has flavor is used as a subject, in those cases, where it's used as an object, in those cases, where it's used as a predicate, which is the most useful information here, since it tells us things such as the Bancroft Chardonnay has flavor moderate. I don't know what that means because I'm not a sommelier, but you know, to someone that may be valuable. Now, importing RDF formatted data is all well and good, but very often in reality, our data is not RDF formatted. Very often it's in formats such as CSV or comma separated values. What to do then? Well, we can use a useful feature called Ontorefine. There we go, to import the data. But first, we'll create a new repository. Now we'll create the repository from a file, which allows you to automate things. So instead of going through the standard workbench method, you can create a turtle file and just use it to upload your repository. Now we have a template which ships together with the GraphDB. It's under, no, it's under lib, I believe. Tools, work, configs, yes, it's under configs, templates, worker turtle. We're going to edit this with Notepad++. Now, why I want to touch it is because it will have this repository ID, which is not nice, repository ID worker test. I want to say that it's MovieDB. And the label, we can also use the label GraphDB movie repository. There we go. And that should work in theory. If I go here, inside configs, templates, worker turtle. However, the entity and ID size has to be either 32 or 40. And as we can see, the entity ID size is also holds some other information. So we can just switch it to 32 like that. The benefits of entity index size has to be a number. Well, that's why I don't do live demos, we just pre-record them. RDFS files are delimited, non-interpretable predicates look like that, query timeout. You can use this. However, since I'm struggling with it, I'm just going to do it the old-fashioned way. MovieDB, which is a worker, has disabled all, same as RDFS plus, the exact same thing, which I was just trying to do. And we're going to use tabular data for that, Ontorefine. So now Ontorefine is based on the Google OpenRefine. So if you trust Google, not with your private data, you can trust us. So what I'm going to do here is I'm going to go and use the movies metadata short CSV. Which is very short snippet from IMDb, I believe. It tells us useful things such as, is it a car movie? Who's the director? How many reviews does it have? This here is Avatar, in particular, on #1. This is just a preview. If I want to create a proper project, I need to click on the Create Project button. Now, starting with this, we see that the first row, which is the identifier, is color. That's not great because some movies don't have color. So what we want to do is first expand this because we don't need the facets and undo redo currently. We're going to discuss this in a while. And then we want to grab the title because movies tend to have titles, which would be here. We want to edit this column and move this column to the beginning. So now we have nice identifiers for all of our movies, hopefully. Another thing which URLs don't really like is this thing, which is fairly small. It's white spaces. We don't want white spaces inside our properly URL formatted database. So we're going to grab actor1 name. We're going to say edit column, add column based on this column. We're going to call this column actor1 without a name in the end to separate it from the other column, and say that value replace, want to replace a white space with nada, nothing. There's no syntax error, and here we have a preview telling us that what we want is exactly what we get. We're going to do the same for actor2 and for director as well. So actor2 is going to become actor2, and director name is going to become just director. And also we're going to strip the white space. Now, you may have a variety of those data sets which are comma separated, and maybe they all have the same pattern with actor1, actor2, actor3, director name. And what you just saw is tedious in a way. Like every time you need to click the same buttons, same buttons, same buttons. So maybe you want to automate this. Well, you're in luck because here in the undo redo, we have all the operations which we just did. We can extract them and we can apply them to any other database. Why do it manually in this case? Well, I just wanted to show you off how it happens. A facet or a facet is a way to filter our data. So here I can create a text facet, and it's going to tell me that there's black and white, color, and blank movies. So I may say that I want just black and white movies. There we go, we just get black and white movies. However, since I want all my data, I can just remove this currently. Moving on, what happens here is when you open an OntoRefine project, it creates a temporary and invisible repository for you. And in this repository, you can carry out standard RDF operations. So here, if I click on the RDF button, I get this screen. And I want to base the IRI on, to use the prefix MDB, just like IMDb without the I part. Everything else is going to be defaults. Select, roll, MDB movie title, etc., etc. I can run this and voila, I have the database, which you can see in Refine here, has now been selected. Now this is all wonderful, but it's still not RDF. What I can do is generate a construct, and if I click here, it's going to RDFize it. So it says that MDB avatar has actor1 called CCH founder. Avatar has color, and it's made in the USA. Now, as I mentioned, this is ephemeral. This is not inside of your main data store. If we want to move to our main data store, I can click the Open in Main Spark Editor part, which will take us to the main Spark Editor in a pop-up window. So now that I've allowed the pop-ups, here is the main Spark Editor. We have the prefix, the SPIF, the construct. What we also have is this part, which says service. The service is OntoRefine, and this is the particular project ID. And if I click Run, there we go. The example MovieDB avatar has actor 1 CCH Pounder, and it's from the USA, and it's with cover. Now, if I change the construct to insert, I can get this data inside my database. Of course, insert doesn't like limits, so I can drop this. Now, since there are a few other transformations which I would like to perform before I actually work with this data, and we're running a bit short on time, I'm just going to import the properly formatted database. Right now, movies Turtle. Turtle is one of the formats for importing data inside an RDF database. Now, what I can do with this data is explore it. I can go to the graphs overview, look at the default graph, which is going to show us a variety of things. What's the movie, it's same as, and so on and so forth. And if I click on one of those, I can see something about, say, movie 12. Kevin Spacey, Marlon Brando, Frank Langella. Not very useful. Or actually very useful, but not very representative. So what I'm going to do is go to the autocomplete. Autocomplete helps us type things faster. It just gives us completion on our RDF resources. I'm going to turn on the RDF autocomplete index, which is going to take a short while, probably a few seconds. I'm going to go to Explore. From Visual Graph, I'm going to look for Charlie Sheen, not Charlie Sheen for us, but I can instead look at Charlie Rowe, for example. Charlie Rowe is the first actor, or the lead actor, I guess, in movie 495, and the second actor in movie 2727. If I click like this, I double click on the movie, you can get various information about it. What's the country, what's the second actor, what's the third actor. You can do the very same with the other movie. You can pin those into a particular location so they stop spinning. And movie 495, that's not very informative. What we can look for is what its actual name, which in our case is Walking with Dinosaurs 3D. And this is the title, Walking with Dinosaurs 3D. So if I go towards the Visual Graph home, which I need to deselect this, and I believe that the X button is just behind my webinar software. So I'm just going to re-click from here. Graphs Overview, Visual Graph. There we go. Create Graph Config. We can start with Node Basics and direct type, label, and rank. We can say that the preferred label is sourced from title. And it is still a label. There we go. So this, in theory, if I save it, and I provide a config name, of course, title, label. In theory, if we save this, it should now work. In practice, maybe it won't. As I mentioned, live demos. Hey, surprisingly, it works. So Charlie Rowe is the first actor in Walking with Dinosaurs 3D, which sounds like a wonderful ripoff of Jurassic Park. But I believe it's a documentary of some sort, maybe a popular movie for children. Never let me go, he's a second actor there. And this is how we can continue exploring our data. Moving on, since this is it's an enterprise cluster. Well, it's not a cluster, it's an enterprise instance. Here we can have a SOAR or a Lucene or an Elasticsearch connector. Now those connectors allow you to integrate with those services. Lucene is available for standard edition and for free edition as well. And it's also bundled inside the database, so you don't need to run a separate instance. Elasticsearch and SOAR are external. A lot of our clients and a lot of our bespoke solutions, which we also offer, use Elasticsearch. So if I click here, I may create a new Elasticsearch connector. However, this is relatively short and we're running out of time. So what I can do is go to Sparkle and create the connector only with Sparkle. Hopefully. So I'm going to go to the Elasticsearch connector.txt, which actually doesn't contain a txt, but a properly formatted query, which says wine, hazier, it's made from grape, etc., etc. Now I can run this, however, we're on the movie database. So first we should switch to the wine database. If I run that, it's going to start creating the connector. Hey, it's created it successfully. I can now open up the Elasticsearch query, which tells us, I believe, what wine was created in what year. I can run that, and I'm going to get no data since this is based on another example data. So what I'm going to do is open up the Elasticsearch data, which is another sample of wine. I'm going to go to import RDF and import as a text snippet. There we go, Blanquito, Rosová, Noiret, Franvino, your wine. Since the Elasticsearch connector imports dynamically, as we perform various operations like importing and modifying our data, should have imported properly without needing to rebuild it. And if I run again, voila! Now we know that the entity, your wine, is made out of Cabernet Sauvignon grape, and it was made in 2013 without needing to rebuild anything and with the proper sample data set. Finally, I would very quickly like to show you the FactForge, which is another of our demonstrators. It aggregates news from the internet. Why I want to show you FactForge? Well, beside the fact that it's a wonderful resource for testing out how GraphDB works with a preset and fairly large data set, it also has this useful feature called similarity, which is the very same feature which I mentioned in the release notes. So if I look at the own news and look at the term, say, in the news, what's there in the news which is popular? Donald Trump is fairly popular. He certainly is there in the news. If I search for Donald Trump, what are we going to see? Well, Donald Trump is very similar to just Donald and to just Trump. That's the similarity confidence index, so to speak, 0.9. Whereas if we had Donald Trump specifically, it would have been 100. Trump's president, yes, he certainly is the president. Campaign, he used to be in a campaign for being president. Republican election, presidential house. I wonder why that's up here. AIDS, Hillary, elect, white, Pence, white for the White House. Pence, that's his vice president, I believe. That's useful if you have a large data set and you want to establish the various relationships between them. You also have useful things in GraphDB such as RDF rank, which tells you how popular an entity is by calculating how many edges it has, how interconnected it is with the rest of the data set. You have useful things such as the cluster, which allows you to cluster master and worker repositories, etc., etc. Here you can see where you can get support. Of course, the GraphDB support email is probably the top location. But if you just want to look at Stack Overflow, you can look at Stack Overflow. There's also our website with documentation, where we store our white papers, various links for RDF, RDFS, where to get an overview of Sparkle, and what's the Sparkle 1.1 update. Thanks for your attention, and it's been a great pleasure presenting to you. I'm sure that my co-host also liked it a lot. We're now going to look at your questions.